Hey guys, welcome back to science. This is our very last lesson in our unit about sound and patterns. So last lesson we were encoding images and we were taking a picture and turning it into binary code. This time we're going to do the opposite. We're going to decode messages. So I have a message in binary that my husband gave to me, and I'm going to try to decode it and figure out what that image is. So we are going to come to the code communicator and we're going to click decode. We're going to click black and white image large. And if you're doing this at home, if you'd like to, you can click sample code and it'll give you one that you can try to decode. Since my husband gave me one, I'm going to click live code. And I'm going to put in the binary that he gave me. And then once we're all done, we can click show colors and we'll see the image. So I'm going to start with the top left. So it says 1, 1, 0, 0, 0, 1, 1. 1, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 0, 1, 1, 0, 0, 1, 0, 0, 1, 1, 0, 0, 0, 0, 1. Oh, oops, messed up. 0, 0, 1, 1, 0, 0, 0, 0, 0, 1, and 1, 0, 0, 0, 0, 0, 1. Ooh, okay, let's click show colors. Whoa, okay, so we decoded this message, and look, it's the letter M. Very cool. Please feel free to try this at home. You have all the login information. So how accurate was the image that we decoded compared with the original image? Well, he said that that was exactly the image that he had in mind. And this is very similar to the way that digital devices send and receive information, because it uses binary code, just like digital devices do. We sent the code across the distance, and the receivers decoded it on the other end. And binary code is useful for communicating across distances because there's only two numbers to use, so it's really easy to communicate, and it's less likely that you'll make an error. Remember when I was trying to describe it, we made a lot of errors. This is much more accurate. So this is a zoomed in image of a computer. Okay, so if this is our computer screen, we're zooming in on just the prongs of the fork. And when digital devices send images, they're using binary code, just like we did. If we look closely, we can sometimes see the grid-like pattern. Okay, and these are called pixels. So each of these squares, each pixel, has a code for its color. These codes are combinations of zeros and ones, just like the codes that we used. So digital devices can send and receive information across long distances, and these devices let us receive an image that looks exactly the same as the original image from the sender. So the big thing I want you to take away from today's lesson is that humans use patterns to communicate information, and they use technology to communicate those patterns across long distances. Now you guys have one final writing assignment. So we have a diagram here, and we need to explain the pattern in this communication. So Maria was working on homework quietly in her living room. Her brother was playing music on his computer on the other side of the room. Suddenly, something about the music changed and surprised Maria. Maria was so surprised by the change in the music that she jumped. The sound from the computer looked like this. So we have a waveform. This is the waveform that shows the music before Maria was surprised. This shows when she was surprised and the music after she was surprised. So what happened? What can we tell from the amplitude and from the wavelength? What can we tell about what happened? So your job is to look at that diagram and then write a scientific explanation in the Google Doc to answer the following two questions. How did the sound get from the computer to Maria? Include details about how the sound energy traveled through the air. And why did the music suddenly surprise Maria? In your explanation, include details about the labeled sound diagram that we just looked at here. I look forward to reading your explanations. Good luck and happy working.